Hello, and thank you for joining the University of Waterloo Fall Open House. My name is Maud Gorbett, and I'm an associate professor and the program director of the Biomedical Engineering program. And I'm going to be sharing today some of the information about the Biomedical Engineering program, and you will often hear me refer to it as BME because this is how we refer to it as a short form. It's an exciting program to be in. The program started in 2014, and our cohort has been growing from 40 students to over 100 students. And it's been amazing to see where our students go in the biomedical engineering and healthcare world afterwards. So in today's session, I will be answering some of your questions about the BME program. First of all, what is biomedical engineering? Is the biomedical engineering program right for you? What will you learn during your degree, during those almost 5 years that you're going to spend at the University of Waterloo? Also, where will you study within the Waterloo region? What is it like to be a student in biomedical engineering? And also, what are the career opportunities after you graduate from the undergrad program? And so what is biomedical engineering? So biomedical engineering lies at the interface of engineering and life science. And it is an area where we use engineering concepts. So we apply math and science to develop solutions that improve human health. And so when you're looking at biomedical engineering, because it has all components around biomedical and engineering, we're looking at combining knowledge from many domains. And so the little graphic on the right side is showing you what are the different domains that you will be learning about during your undergrad study. And so as you can see, we're looking at various disciplines from engineering, looking at electrical engineering, chemical engineering, systems design engineering. We're also looking at math and statistics, many areas of science, chemistry, material science, anatomy, biology, and also thinking about applying computer science, so looking at artificial intelligence. And so when you're looking at biomedical engineering, it is clearly an interdisciplinary field that is combining all that different knowledge from many domains, and that helps us create solutions that can address real world problem in health and the medical community. So is biomedical engineering right for you? So as you may know, it's a very emergent field and growing field. There are many industries now that are growing and to develop solutions to address issues in healthcare and in the medical field. And when you're looking at it, you're looking at developing technology to help resolve those issues. And so when you're talking about technology, you're talking about technical education, engineering, and life science. And so as we're looking at this, you have to also think about the difference between being a biomedical engineer, but also and a doctor. And so the difference between biomedical engineering and biomedical science, for example. And so as a biomedical engineer, you will develop solutions to help a surgeon, for example, to work within this surgical suite. You will not be interacting with a patient like a surgeon would. And so that's a little bit of a difference when you're looking at trying to understand, I'm interested in healthcare, but do I want to become a doctor or do I want to become an engineer? As part of developing engineering solutions, there's also a lot of design thinking. So thinking about who are the player within the space that you're developing a solution. So we call those stakeholders. So some of them are the patient, some of them are the medical insurance company, there's a healthcare system, there's a patient, there's a caregiver. And so as you develop a solution, you need to consider all those different stakeholders so that you can address their needs appropriately. So as part of this, when you were looking at developing a solution, because it looks at different areas of knowledge and also medical application, you're never going to be working alone. And so as a biomedical engineer, what you would see is that there's a strong emphasis on teamwork and collaboration, where you will be working with members of a team that have potentially similar skills that you have or different skills, and also thinking about collaborating across discipline. And so during your degrees, there will be a lot of emphasis on teamwork and collaboration. as you're looking at becoming a biomedical engineer, we're thinking about the system approach, where we want you to see the big picture as well and understand the details, the interaction, input and output. Because as you develop a solution, there's always interaction between the various components of your solution. And you also need to consider how those may impact different stakeholders as part of it. So what will you learn in your degree? So it's important to know that you're going to be working towards a Bachelor of Applied Science in an accredited engineering program. The program is housed in the Department of System Design Engineering, which also has its own undergrad program. And so you will be learning the design thinking framework and apply it to human physiology and solving healthcare and medical related problems. And so as part of it, you'll have a solid technical education in engineering, science, physiology, and much more. The curriculum has been developed for the biomedical engineering program. And so when you're looking at all the courses that you will be taking, they have a biomedical and a design focus. So in your courses, although you may be taking fluid dynamics, for example, we're going to ensure that there are application toward the biomedical component of those. So there's context applied directly to human physiology, for example. As a biomedical engineer, you're going to be developing solution. And so we need to ensure that you can understand the technology. And so experiential learning in labs and workshop is really important. And so that will be part of your education. Also, as part of it, when we're looking at training you as a biomedical engineer, we will give you the fundamental knowledge that you need. And as you move into your years of engineering training, you will take technical elective that will allow you to specialize or gain more knowledge in a certain area. There's also what we call complementary elective that are important to ensure that you get education that is also outside engineering and science. And so looking at languages, social sciences, psychology, so that as a biomedical engineer, you also have an education outside the engineering field. Finally, the program culminated in the capstone design project, and it's a fourth-year team project where you will conceptualize and design a solution to a health-related problem. And this is done as an independent team. And so you select your team, and then you select the problem, and you have 8 months to develop that solution around a problem that you identify that you believe is important and there's a need for it. When we're looking at our curriculum, so you may know that this is a mandatory co-op program. So every student that will enter the biomedical engineering program will do 6 co-op work term, 5 are required for as a degree requirement. And the way it works is that you start in first year, so the fall 1A, and then you go all the way to winter 4B, 4.5 years later. And what you will see in the slide that has a lot of different courses and can be a little bit overwhelming is that the first row you will see as the courses that relate mostly to design, biomedical design engineering, which is, as I mentioned earlier, a key component of our program as it helps us ensure that students can apply the knowledge that they gain and the skill from their other courses to develop solution and prototype, for example, validate their design, or learn how to validate and test their design, for example, in the BME design in 3A courses. If you look at the various courses, you can see that we have various courses in math, in science, in physiology, biology, digital system. You also have some programming that you will need to do, because that's a tool that as an engineer you will need to model and simulate, and that will help you test your solution and better understand how it might work in the real world. Toward the end of the degree, you will be able to select courses which are elective, so either technical elective or complementary study elective. This is also, as it highlights your various co-op work term, What's important to see also as part of this is that all of the courses that are labeled as with a course title are courses that you have to take. So this is another difference that you may see between biomedical engineering and biomedical science, whereby in biomedical science, if you're more interested in a health-related field, you will not have to take those mandatory courses. As an accredited program, professional engineering program, those courses that we have listed here have to be taken. And so that's an important distinction to make between biomedical engineering and biomedical science. And so as there is a lot of information on this slide, something that I really want you to take as a takeaway also is that this program offers a robust and interdisciplinary engineering and scientific education, as you can see. So while there are many mandatory courses that you have to take, we also have courses that will allow you to specialize. So when you're looking at the mandatory courses that you're taking, they are related to certain area of biomedical engineering and key fundamental knowledge and skills that you need to have around, biomedical signals, because our body, there's nerve function, it's an electrical stimulus. So you need to understand how those signals work. Biomechanics is also important because our body moves. And so we want to make sure that you understand how the physics and the science behind it so that you can develop a solution that works within this. And biomedical device, because this is a technology that we can use to actually help and solve those problems, health-related and medical-related problems. And so those are the team area where you will see our courses weave into our curriculum. And towards the end of your degree, when you can start taking elective, you can actually specialize. We now have 5 specializations. And what we mean by specialization is that those technical electives that you would be taking are a little bit more specified and constrained. Within the engineering degree, you can take many different electives across the various engineering programs, with a specialization that we have listed in biomaterials and tissue, medical devices, medical artificial intelligence, neural engineering, and sports engineering. What happened is that you have a technical package, basically, that you have whereby you select your 5 technical electives within a specific list. And within that list, those courses allow you to gain depth within that specific area. And so you can potentially combine, biomaterials and tissue and medical devices as a specialization, or, medical devices and medical artificial intelligence. So that allows you to tell your degree in a certain manner with having a specific list of courses that you can select from as part of it. So the biomed faculty and staff, so as an undergrad student in a program, what you will have to support you is many people that are really keen and engaged, and making sure that you have a great experience as an undergrad student in our program. First of all, you will have a biomedical engineering academic advisor that who is there to support you with all aspects of your academic career and guide you through on-campus resources. We have faculty members that are doing cutting edge research in the team areas that I mentioned, in medical imaging, in biomaterials, in biomechanics, in artificial intelligence. And we recently hired 2 new faculty members who are doing research in wearable robotics and micro robot for surgical purposes. And as an example, the picture that you see on the side is from Dr. Persina Giriza, and is one of our faculty members in doing medical imaging, and has been also one of our instructor, and he would be teaching you digital system and also medical imaging. And so we have some fantastic instructor and researcher as part of it, where you can also do some research during your undergrad degree. We also have a lecturer team, so instructor that are dedicated to our teaching and that help support our design curriculum. Finally, as we mentioned, is that there's a lot of hands-on experience. And so we have technical and lab instructor that are there to support this experiential learning. And as part of that, the program is also collaborating with the School of Anatomy and the Department of Biology and the Faculty of Science to provide you with enhanced experiential learning in biology and anatomy. So where will you study? So we do have various areas where you're going to be able to interact with your cohort, with your student. We have classroom in engineering 5 and 7, which are buildings that are about 10 years old, very recent. We have study space. We have our labs that are located in this area. And we also have BME dedicated lab in the DW or Douglas Wright Engineering Building, where we have a biomechanics lab and our tissue engineering lab situated there. We also have a prototyping lab. We have workshop spaces that you can have access as an undergrad in biomedical engineering. And you can also access 3D printing, laser cutting, and we also have what we call the Den, which is resources where you can borrow various equipment such as sensor, cameras, and other equipment to be able to do your design project and eventually your capstone project. What you see on the side on the picture is actually our biomechanics lab in the DW building, where our students are actually doing some mechanical testing of bone. So it's an artificial bone and understand the mechanical properties based on those. So what is it like to be a student in biomedical engineering? So what happened is that you start in first year, and we are what we call the cohort-based system. And so you will start with about 100 of you, and then you're going to be together for the next 4.5 years as part of your academics. And so there's a strong feel of community as part of our program due to this cohort system. It's also a very welcoming and supportive community. Our students are wonderful. Our first year are being mentored by your second, third, and fourth year. There's resume critique that occurs. There's design project critiques that occur so that upper years can help junior years with their design project. And so not only will you gain great team experience, but you will also create connection with your cohort, but also with students that are in upper years as part of our program. So while we work together, we also celebrate together. And so we like to have social event as part of our program. Sometime you will have coffee and cookies during a break. We will also have pumpkin carving, game night. We also used to have a coffee house before COVID-19, and hopefully we'll come back. And the picture that you see is actually the time where we celebrate our graduating cohort. And so we are wearing masks. And so you can see this is just from last year, as we celebrated for the first time in person again, our graduating cohort of 2022. And so this was really exciting. And this is a time where we can share the achievement of our fantastic student. As part of our community, it's also great. We have our own floor on the 6th floor of engineering 5 and 7, sorry. And you will also be able to study there. There's also a piano where you'll be able to play or listen to some of the wonderful talent that our students bring with them. So not only, great academic skills, but also very talented people on many levels, at the athletic level, but also artistically. So as a biomedical engineer, what kind of career opportunity will you have? So as I mentioned earlier, biomedical engineering is a mandatory co-op program. So you have 6 co-op of 4 months each. The last one that you have after your third year, is an 8 months co-op. And so that allows you to work a little longer on the project that you will be assigned to. And so during that time, all the co-op allow you to gain 2 years, of paid work. And we have extremely good placement with a BME student. Usually it's 99% and above a student that will be placed from first year to third year within that. And the benefit of co-op and having, 5 or 6 of them is that this kind of allows you to taste basically various area of industries, but also roles. And so you can get a sense about what you're interested in doing from moving between jobs and potentially roles, and also between industries. And so, for example, you may not be sure if you want to focus on medical imaging or something that's more related to, tissue engineering or biomaterials. And so through your co-op, you can get some of experience and get a better understanding about what the field is about and if this is where you want to be. Through your co-op, what you can also do is that you can acquire technical skills that you may not be able to have access to during your academics. And so often we see our student in first and second year sample out the various role and move around between industry. And then in upper years, they may actually select the co-op based on the kind of skills they're interested in gaining. And so it will allow you to be able to work in various environments. And so as you can see from the various logo that we have on the slide, when we said that biomedical engineering lied at the interface of engineering and life science and medicine, you can see that there are industries such as Bailey's Medical, IntelliJoint, Nakoya, which are small and large companies, but we also have a student working, in a hospital, the University Health Network, all in Bloorview, doing research such as at Harvard University and NASA and other University of Waterloo lab, for example. And so you can clearly see that as a biomedical engineer, you would be able to gain experience in small, large, not-for-profit, for-profit businesses, and that will help you determine where you want to be after you graduate. And so talking about graduation, where do our graduates go? And so it's been really exciting for us to see where our cohort and our students have gone after they graduated. And so we graduated our first cohort in 2019. And what's been amazing to see is how they've been able to go work in industries, do their own startup, enter graduate school, and do much more. And so I'll give you some example about our alumni. So for example, you see Simona Rocco. She's a recent graduate. She is now a management consultant in the healthcare industry. And she's been basically doing consulting work. So working on different projects as part of this position that she has. Ryan Tennant was an undergrad student from the first cohort. He basically developed an app for the COVID-19 vaccine, and he's now doing his PhD in system design engineering. On the left again, we have Nathan Duart from the BME 2021 cohort, who was a recipient of the Michael McCain Scholar at McGill, and he's doing a master degree around biosensor. And finally, you can also go towards more other business areas, so law, medicine. And as an example, we have Mackenzie Collins from 2021, who is now in an MD and PhD program at Queen University. And so as you can see from this slide, there is unlimited potential for a graduate to go in industry or to go towards graduate school, higher education, and also enter law or medicine if they're interested. And we actually have some students that are just entering law at this time. And so I wanted to leave you with this picture and this message about, how wonderful and robust program that we have. Biomedical engineering is a cutting-edge interdisciplinary engineering program where you will learn in a community environment. And our program provides a strong engineering education with hands-on learning. And as you can see, it opens the door for many career opportunities to work and develop the next generation of health and biomedical technology. And so we thank you for considering Waterloo and our biomedical engineering program. And so if you want to learn more about the biomedical engineering program, you can go on to our website. You can also connect with Waterloo Engineering on social media. And if you have any question, you can use chat. You can chat with our engineering student ambassador. There are also admission questions you can send. And you can also see some example of what our undergraduate students are doing. So again, thank you for joining us and take care. Bye.